Hello, everybody. This is Javier Ortiz, your mentor throughout this program. Welcome to another webinar for the Data Engineering at a Degree by Udacity. So before we begin with today's webinar, a couple of announcements. Remember that you can post all your queries at DEND session 963. This is where a study group resides, and each week on Tuesdays, I'm posting a weekly roundup where I post all the lessons you have to go through that weekend in order to be on schedule, along with any scheduled events such as this webinar, the Calendly link to schedule one-on-one meetings with me, and any deliverables that we have due. All right, so don't hesitate to ask whenever you have a question or in a project. All right, that being said, let's get started. Right, so today's webinar will be focusing on writing Parquet files. Let me open that up for you. Awesome. Writing Parquet files. These are actually our webinar 12, and we're going to do a small project overview. If you didn't watch the previous webinar, go ahead and watch it. You can find the link on the DEND 963 session, our study group. I provide a deep walkthrough of the project, so you should definitely watch that for Data Lakes project. And we're going to cover what are Parquet files, then how to write them, and finally partition in Parquet files. So let's get started with project overview. So let me go to where the project resides. So as with previous projects, Udacity provides you with a project workspace. Here's where you code the majority of your project, and basically there are three documents, but two documents you have to code. And the first one is the dl.cfg, where you basically have all your AWS keys, and the ETL, which is where the code of your project resides. Now we start with setting up the config just to get your credentials from the other document, from the DL document. Then we create the session, and what we do, we are trying to get the files from the S3, which is where they reside, and we are reading those files into one data frame. We are selecting certain columns from that data frame to create a table that we would like to create, and then we find our topic for today's webinar, which says write songs table to Parquet files, partition by year and artist. So what we have so far, we have read our credentials. With that, we have created a Spark session, and we have walked this path to get all the files inside the S3. We have read those into data frame. We have selected certain columns. And now that we have selected those columns from that data frame, we want to write that data frame back to the S3, right? But the way we write it back, we want to write it back as a Parquet file, which is a special type of file. So what is a Parquet file? I mean, it's pretty straightforward to read all these files into one data frame and select all those columns from that data frame to create a new data frame / table. Why can't we just write that table back to S3, and why do we need to write as a Parquet file? So that's what we'll be covering today. Back to the presentation. So what are Parquet files? All right, Parquet files are columnar databases, all right? So in the simplest way of saying it, they are databases, but they store data in columns instead of rows, all right? So you have to think that the way we typically write, a program typically writes a table is that it populates the table row by row. So it writes all the data associated with the first row, then the second row, then the third row, etc. But here, the way we're going to write this table back to the S3 we're going to write all the data that belongs to the first column of the table, then all the data that belongs to the second column, all the data that belongs to the third column, and so on and so forth. Now we do this because these columnar databases increase efficiency to speed up the time it takes to return a query. So that when we do a query like select, asterisk, from, or we want to select min or average or max, if we want to do this calculations, these queries will return a lot faster than if they were ran in a normal database, right? So you may ask, why do they run faster? I mean, does that make really that much of a difference to populate a table row by row instead of column by column? And when you're dealing with a small databases, this might not be like a big difference, but remember, here we're working with big data, so it does make a difference. All right, so let me give you an example. Let's say, let me move me out of the way. Let's say that we have this table, right? With an ID column, last name column, first name, and the bonus we're going to give to each of this, all right? So pretty straightforward, nothing fancy here. Now, the way we typically write this table, right? And let's say we want to write this table back to the S3, and the way we would write this into disk or into the S3 bucket, we will write all the values from the first row. One, which is the ID, last name, first name, and the bonus. Then we'll move on to the second row, third row, that's it, right? But the way we would write this table as a Parquet file, we will write all the values for the first column, 1, 2, 3, all the values for the last name, Doe, Smith, Beck, all the values for first name, and all the values for bonus, right? So as you can see, the values that we have as a column, you have to think of them that they live really close together inside disk. The space they take inside disk, they are really, really close together, all right? So imagine this is your actual disk, and each of these values from the same column, actually, they live pretty far apart. I mean, not pretty far apart, but farther apart than the ones that we have really close together here in our disk, inside our disk. And remember, the disk is a physical object, and it does take some actual time to read from one section of the disk to the other section of the disk. So data is highly compressed. Now, this facilitates making easy columnar operations such as min, max, sum, count, average. Such operations are usually made as aggregation of all the values in one column, all right? If we want to get the minimum value, we want to get it from the values of the same column. It doesn't make sense to get a minimum value of values of the same row because the values will be really different one from the other. But for example, here, let's say that we want to get the sum of the bonuses that we want to give. If we were to do it in a regular database, we will have to read these 8,000. And then we'll have to move to the space in disk where the 4,000 resides and read it. And then move again to the place where 1,000 resides and read it. And then we'll have our answer. In contrast, with a Parquet file, we have these three values that we want to aggregate really close together inside the disk. So we would read the 8,000, and right beside it, it will be the next value that I want to read. And right next beside it will be the next value. So it's a lot faster to read. Now, here it doesn't make sense because we only have like 3 rows, we have 3 values per column. But imagine if you have millions and millions and millions. So this type of compression really accelerates our queries and what they return. So that's why it's so important to write these Parquet files when you're dealing with big data. All right, let's move on. So let's move on to how do we write these Parquet files. All right, so it's really, really simple. We'd start with our basic data frame. You already know how to read a JSON file or a series of files into data frame. We use the spark.read.json, and here you provide it with a file path. And data frames can be saved as Parquet files, and it will maintain the schema information. So if we just take the name of this data frame and write .write.parquet, and then we specify the name of the Parquet, the same data frame that we had, we're going to write that as a Parquet file, and that's it. So instead of writing that data frame row by row, we're writing it column by column. Now, if we want to read that Parquet file created above, the schema is preserved, so the result of loading a Parquet file is going to be also data frame. So here we have a Parquet file. We're going to equal that to spark.read.parquet, and then we read the people.parquet. And this will serve as a data frame. We're reading this Parquet file, people.parquet. Now, Parquet files can also be used to create a temporary view and then using SQL statements, which is really cool. So here I have the name of the Parquet file they are just read, then create or replace temp view, and we're going to select Parquet file. This will be served as the name of our table. And here I'm going to use this variable to hold this SQL statement. So spark.sql, and I'm selecting a name from this table from Parquet file, and I'm doing a where statement. Age is bigger or equal to 13, and age less and equal to 19. And then I can show the result. So basically you have to first hold all your values, your data into data frame, and then you can just read it into a Parquet file, and it will preserve the schema, which is pretty cool. All right, let's move on. And now that we know how to write these Parquet files, let's go with partition. Now, partition is just another way of speeding things up with your queries. So what we do with partition, the way you have to imagine it, is that you create like subfolders inside that file. So for example, let's say here we have our table, and we want to partition by gender and country. So what we would do is, imagine that we have a subfolder of gender equals male. So here inside this folder, I will have all my results, all my data that matches gender equal male, right? So I wouldn't find any rows where gender equals female. So you can see already how this would speed up our queries, because if I'm doing a where statement where gender equals male, I would only have to look inside this folder, and I already have all my data partitioned inside this folder. So instead of going row by row checking if this meets my where statement, the computer just goes inside this subfolder and knows that everything is going to match, right? And then you can go even further. You can do another partition by country. So if you have like a where statement of gender equals male and country equals US, I know that I have to go to this first folder and then this next folder, country equals US, and I know that everything right here will match the where statement, right? And here you can see that I have two partitions for gender, male and female, and then I have a partition by country on each of them. So that will really speed up all of your queries. Okay, so how can we write them? How do we see this applied in the project? Well, let's see it. All right, so we are here in the project. We have this data frame where we are reading the columns song ID, title, RSID, year, and duration. So we already know that we can use this data frame to write a Parquet file, right? So I'm taking the name of the data frame, I'm writing that, and I want to partition by. This will create the subfolders that we mentioned. So first, it will partition your data by year. So you will have all the subfolders by each year. and inside each subfolder of year, you will find a subfolder of artist ID. So when you look up some row, you're going to go directly to the year, and inside it, you're going to find the info of the artist ID that matches that year, and then you will find the song ID, the title, and all the rest of the info that you need. All right, so here I set up the partition .parquet that establishes that I want a Parquet file, and then I provide a file and basically the name along with the file. So I'm using the os.path.join to join this initial file path with this songs, which will serve as the name of the file. All right, so what should I put here in output data? Well, you find this variable all the way in the bottom here. And the output data, you see, I pointed to the same S3 as where all my data resides, but I'm pointing also to an additional folder that is called analytics, so that when the analytics people, the analytics team, go inside the S3, they can. Oh no. Here, instead of finding all the files as the JSON files, they know that here inside this folder analytics, they will be able to find these tables that follow this star schema that we want. So my table will be written in this file path, and it will end with the name of the table, which is songs, right here. Okay, and finally, you want to add this override. What this override does is it allows you to run this ETL many times. And every time you run the ETL, if the data, and every time you run the ETL, if you have additional files, these will obviously update this data frame. And when you update this data frame, and you select the columns, you will have other rows that you didn't have before. So you want to write them in the Parquet file. But if you don't write the override, you won't be able to write these new rows into the Parquet file that you created the first time that you ran the ETL. So that's why it's really important to write to include this override. Okay. And you repeat the process over and over again for each table. As you can see here in artist table, we are actually using the same DF because DF basically stores all of our JSON files. We're selecting the columns that we care about. And once again, we're writing this Parquet file. This time we're not including the partition by because it's not required for us. In songs, it does make more sense to include this partition because it's going to be a lot faster. You will have lots of songs, and it's going to be a lot faster to partition by year and artist ID. But with artists, I mean, it's pretty straightforward, so there's no need to partition your data to make it faster. And don't forget to include the override. So we'll do something similar with the others. I don't want to go to make another walkthrough of the project, of the whole project, because I already did that. If you haven't checked that, you should definitely check the video that I did last week, which I share here at the DEND session 963. As you can see, it's right here, Data Lakes project walkthrough. So definitely watch that, and if you in that video along with this one where we go over how to write a Parquet file, should definitely set you up to finish the project by yourself. Remember, this project is due this Tuesday, so you definitely want to spend the rest of the weekend working on that, and I'm confident that you'll be able to get it done by then. Once again, if you have any other questions about Parquet files or about the project, don't hesitate to ask through the DEND session 963, or send me a DM, or schedule a one-on-one meeting with me. I'm here to help you guys and help you be successful on finishing these projects. So I will see you soon. See you next week. I'll be posting the weekly roundup on Tuesday, and I'll be posting this link in a couple of hours in the DND session 963 study group. So it was a pleasure talking to you guys again. And don't forget, this project is due this Tuesday, and then we move on to the last unit of data pipelines before moving on to the capstone project, which is basically the end of the nano degree. So I'm amazed of how fast this has felt, but this is week 12 already. So 3 months in, and hopefully you're enjoying the project, you're learning a lot, and let's be in touch. All right, guys, see you soon. Goodbye.